All right, welcome to Chapter 6, Section 6, called Triangles and Coordinate Proofs. This is for Integrated Math 2 or IM2. So a couple things just to start off that you'll see on your front screen here. You should always see a due date on your student screen. You don't see it on my teacher screen, but you'll see it on your student side. Number of attempts. You always have unlimited attempts for homework, quizzes, and tests. Number of questions just tells you how many questions are on this particular assignment. Grading policy is always best score, so whichever attempt is the best, the one you keep. Partial credit is always enabled, meaning, if you answer one of two questions correctly, you get credit for one question or however many questions you answered correctly. Please remember, once you start your homework, you must finish it before you can work on anything else. What that means is once I click start, down the bottom right corner here, there is going to be a submit assignment button on your student side. I know it's not here on the teacher preview, but it will be on your student side. And that does two things. Number one, when you click that button, it stops the whole system from locking you out of all your other assignments, just like that first screen said. So it's going to assume that you want to leave the attempt open if you just close the screen, if you don't click submit assignment. Remember, you have unlimited attempts. You can come back in and try this as many times as you would like. So as long as you've finished the problem, you've clicked check, and you have a green check mark here, it's going to save your place. So just always click that button. The second thing it does is it shows your teacher what you've been working on because it affects the grade book. So before you click that submit assignment button, your account's kind of like frozen in that spot. We don't get to see what you've been working on. So good habit, always, always, always click that submit assignment button. On the side here, we have explanation, example, and message center. So explanation tells you you're going to lose your question attempt because it's going to give you the answer to this question. So it's not going to give you the answer unless you come type in the answer. Sorry, not how this works. You're going to have to come in on another attempt and try that out. Example gives you a very specific kind of example of what we're going to be doing, and we're going to be using the distance formula here. So we'll have this guy written out over here in just a minute. So we're going to go through and we're going to use the distance formula to show some of the lengths of these triangles or these side lengths using coordinates. And then you can also message your teacher directly from this screen so that your teacher knows where to come help you. All right, so let's go ahead and look at this specific problem here. So we have here are the endpoints of the segments A, B, C, D, and E, F. So here we see the coordinates. Follow the directions below. So find the length of each segment, which is why we're going to use the distance formula. And then check all statements that are true. We want to decide which ones are congruent to each other. So if you notice, it's boxes, which means that we could have more than one. Or we can have none of them are true. It just depends. We get to go through and check them all. So distance, and I'm going to change the color here just so it's a little darker. Distance equals the square root of the x terms subtracted, so the difference of the x terms. So this is the change in x plus the change in y, or the difference of the y terms there, or the y coordinates. So this is our distance formula. Each one of these has an x and a y. So if we're looking at A, we have 3 and 1. This would be x1 and y1, just because it's the first point here. And then B, this is going to be -2 and -5, and this is going to be x2 and y2, because we're just saying this is point 1, this is point 2. That's all the 1 and the 2 mean. X coordinate of point 1, y coordinate of point 1, x coordinate of point 2, y coordinate of point 2. So we're going to go through and we're going to work this out for AB, and then we're going to do it again for CD, and then we're going to do it again for EF. So it's going to take a few minutes to go through. So we have the distance equals, so we're going to go x2, which is -2, minus, remember there's a minus in here, so it's minus x1, and then that's squared. Plus, we have y2 minus y1 squared. So now I have distance equals -2 minus 3 is -5, plus -5 minus 1 is -6. So I'm just going to go ahead and write this way so I have a little bit more room here. So this is going to be the square root of 25, -5 squared is 25, plus -6 squared is 36. So that's going to give me, let's see, 11, so 61. And it says, give an exact answer, not a decimal approximation. So this does not have a square root. I already know that just because I have my square roots or my squares memorized. I know that 61 is not one of them. The closest thing we have to that would be 64, which would be 8 times 8. So AB is going to be the square root of 61. All right, so now we're going to go through and we're going to go C, and that's -8 and 0. So this is my new x1, y1. So I relabel that each time. -4 and -7, so this is my x2 and my y2. So I'm going to go through and do that again. So I'm going to have x2 minus x1. So it's minus negative. Don't let this -8 take this minus away. We want to see that minus negative because that's actually going to turn into a plus. That's a double negative. So it's very important there that you leave both the minus and the negative because they interact with each other. Plus, now we have y2, oops, not comma, minus y1, which is 0, squared. So I have D equals -4 plus 8 is +4 squared plus -7, and I just realized I wrote that really, really big. So I'm going to kind of take that back a little bit. So I have 4 squared. -7 minus 0 is -7 squared. So now I'm going to have 4 squared is 16, and -7 squared is 49. So let's see, I have 15, because 6 plus 9 is 15, then 4, 5, 6, so that's 65. So again, no square root there. So I'm going to have 65. So now we're going to check EF. So far, nothing is congruent. Nothing is equal to each other. So E is -7, 8, and that's x1, y1. It's my new x1, y1. And then F is -2, 2. So it's x2, y2. All right, so my last one to check here. So I have -2 minus -7. Remember, that's going to turn into plus. And then plus 2 minus 8 squared. So I end up with -2 plus 7, well, that's 5 squared. Plus 2 minus 8, well, that's -6 squared. So then I end up with 25. 5 squared is 25, plus -6 squared is 36. So this added together, this actually is the same thing as up here. So I'm going to end up with the square root of 61. So the only ones that are equal to each other are AB is equal to EF. So I see that in the middle there. So it's the only box I can check. Nothing else is equal. So I'm just going to go ahead and click check, and we are good to go. So we're checking to see what is congruent to each other. And part of the application has to do with this is you can check to see if triangles are isosceles or equilateral based on using this idea of literally calculating the distance on a coordinate grid. I'm going to go ahead and click new. Okay, so determine whether a triangle with the given vertices is a right triangle. So one thing they want you to do in here, and this, it's been a while since we've actually dealt with this idea, but when we're dealing with slopes, we have a right triangle like this, which would mean that the slopes are perpendicular to each other. So this line is going to be perpendicular to this line. And that means that the slopes are negative reciprocals of each other. So that means if this slope, and I know this is straight up and down, this is, horizontal and vertical. So we have a horizontal line, a vertical line, but it doesn't necessarily mean I could have them like this, and that could be my right angle there. So they wouldn't necessarily be horizontal and vertical. That's definitely not a guarantee on your if we actually went through and plotted these. But what we would want to see is the negative reciprocal. So let's say if one had a slope of 1, the negative reciprocal would be -1 because they're both over 1. So it'd be 1 over 1 or negative 1 over 1. Technically, the negative 1 would be on the bottom, but it would move up to the top when we reduce to 1 over 1. Or let's say that it had a slope of 1/2. Well, the reciprocal would be 2 over 1, or just 2. It was positive, it would turn to negative, like that. Or if it was negative 1/2, it would flip over just like that, but it would go from negative to positive. So we have to pay attention to that negative reciprocal idea, but what we need to know is the slope. So we're going to use the slope formula here. So we're going to use the slope for each one of these. We're going to calculate what the slope is for each one of these lines. Remember, we have a triangle. We have 3 lines in each one of these. So we have to do the slope formula 9 times to check all of these, because we need to determine, are any of these negative reciprocals within part A, within part B, within part C. So for this one I have PQ, and I want to know what the slope is, so I'm going to do rise over run. And I actually do this, I'll show you kind of the way I do this in class. I go like this, 5 over 8, and then negative 3 over 6, like this. I've actually just stacked them. So I have my x's and my y's, and I go and I subtract straight down. So I have 8 minus 6, and that gives me 2. 5 minus negative 3, that's 2 negatives, so that's actually a plus. So that's 5 plus 3, which gives me 8. So now, remember, this is run because it's the x's, this is rise. So I'd have 2 over 8, which would reduce down to 1/4. This is the exact same thing as doing the slope formula, so I'll also show you the slope formula real quick. So we have QR, if I do just the next piece here, QR. So I'd have the y's, the change in y over the change in x, which means y2 minus y1, so 10 minus 8 over x2 minus x1, so I'd have negative 5 minus 5. Negative 5 minus 5. And if you notice, if I'm stacking them, I'm doing the same thing. y2 minus y1, x2 minus x1. It just depends on, maybe that makes it a little easier so you don't have to identify those. They're just already stacked in order. I've seen students, they like both of these. Just depends on the student and which one makes a little bit more sense. So I have 2 over negative 10. So I end up reducing that to negative 1 over 5. So far those are not the same, because we'd need 1/4 and then negative 4. Or I'd need, this is negative 1/5, so I'd need positive 5 to be a negative reciprocal. All right, so the last one we're going to do is RP. And I'm going to go ahead and stack my pieces here just because for whatever reason I like this a little bit better. So I have negative 3 over 6 and negative 5 over 10. So I'm going to subtract. So I have 6 minus 10, and that gives me negative 4. Negative 3 minus negative 5. So remember, this is going to turn into a plus because it's minus negative. So I'm going to have negative 3 plus 5, and that gives me 2. This is run. This is rise. So I end up with negative 4 over 2, which gives me negative 2. 4 divided by 2 is 2, and so it's negative. None of these are negative reciprocals of each other. So this is not a right triangle. You're not going to say it cannot be determined. They are 3 sides to a triangle, and we're going to assume it says determine whether a triangle with the given vertices is a right triangle. So we're not assuming that it's not a triangle. It is a triangle. We're just deciding is it right or not right. And either there's going to be a negative reciprocal or there isn't. So that's all we're looking at or looking for here. So we're going to do the same thing for DE. All right, so we have DE, so we have 6, 0, and negative 5, 5. Let's subtract straight down, so we have 0 minus 5, that's negative 5. 6 minus negative 5, remember that turns into a plus, so we end up with 11. So then we end up with negative 5 over 11. Can't really reduce that, so we're just going to leave it alone. And then we're going to do EF. So I have -2 over -3 and 6 over 0. No, I didn't cross off my zeros there. So I end up with -3 minus 0, which is just -3. -2 minus 6, which is -8. So I end up with -3 over -8, which turns into 3 over 8. 2 negatives make a positive. And then I have FD. So I can go -2, -3 over -5, 5 minus. So -3 minus 5, that gives me 8, 9, 10, 11, -11. Sorry, 5, 6, 7, 8. I don't know why I said 11. I counted 8 and then 3 more. So that gives me -8. And then this is -2 minus -5, so that's a plus. So this ends up 3 positive. So this ends up -8 over 3. This was positive 3/8. This is -8 thirds. Those are reciprocals. They're flipped over. One's positive, one's negative. That is a right triangle because these two are perpendicular to each other, which means that they are a right angle. All right, I'm going to erase this so that I have room. Do that last guy there. So now we're going to go AB. We're going to have 9, so 1/5, and -9, 5. So 1 minus 5 is -4. 5 minus -9, remember that turns into a plus, so this ends up being 14. So I have -4 over 14, which reduces. They can both divide by 2, so I'd have -2 over 7. Now I'm going to go BC. So I end up with 9, 5, -7, 12. 5 minus 12, that gives me -7. -7 minus -7, sorry, -9 minus -7, that turns into a positive, so this turns into a 2, a positive 2. So let's see. This ends up being -7 over 2. So there are reciprocals of each other, but they're not negative to positive. It's negative and negative. So these are not perpendicular to each other. And I need to make sure that I didn't mess up the negative there at all. So I end up with negative. I end up with positive. So that's fine. I end up with negative. I end up with, oops, this should be negative. -9 plus 7. So this should be negative. So this ends up being 7 over 2. So these are negative reciprocals of each other. So it is going to be a right triangle. I don't even need to check that third side because we're not going to have two sides or another side of the triangle perpendicular because that would mean we have more than one right angle. So we can be all done. Check. Yay! So again, we're just checking slopes. I know it takes a little bit longer to go through and check all the slopes because we have to do each and every one. So that was section 6. I believe that's the end of chapter 6 at this point. So I will see you in chapter 7.